In a digital communication system employing frequency shift keying FSK, the 0 and 1 bits are represented by this waveform and this waveform respectively. Evaluate the minimum value of the bit interval in microseconds to make these two waveforms orthogonal. Okay, so the condition for orthogonality between two waveforms is that the integral over that interval of the product of the two waveforms must be equal to 0. So if you take a waveform A sine 2 pi f1t multiplied by B sine 2 pi is supposed to be f2t dt, that value of the integral should be equal to 0. So when you proceed to perform that integral and apply trigonometric identities, then you can move from this point to this point, and then that integral simply reduces to this. So you have this value subtract this value over that duration is equals to 0. And simplifying that, you have sine 2 pi f1 minus f2 multiplied by tb over that value should be equal to this. So basically you perform that substitution and you should end up at that point. So the only way this is possible is that this value 2 pi multiplied by f1 minus f2 multiplied by t and 2 pi multiplied by the sum of f1 and f2t should be integer multiples of pi. That should be n pi, because we know that if this value is n pi, then the sign of n pi is equals to 0. It's the only way this relation or this equation can be satisfied. So then that would mean that f1 minus f2 should be equal to n over tb. Basically, you perform that substitution, equate this to n pi, and you can end up with this n over tb, which is also equal to n times rb, because tb is the inverse of the bit rate. That is also the same case over here. f1 plus f2 should be equal to m over tb equals to m over rb. But in our case, we know f1 is 5 kilohertz and f2 is 35 kilohertz. So that means then that 5 kilohertz, which is f1 minus f2, should be equal to n over tb, and 35 kilohertz should be m over tb. And in this case, the values of n and m are basically chosen arbitrarily, but we know they should be integers. Now, the only way this condition on integer multiples of pi, that is n pi and m pi in this case, the only way that can be met is that that bit interval tb will be the inverse of the GCD of these two frequencies. The values of, for n and m to be actually integers, then we know that then that bit interval delta t must be equal to the GCD of 5 and 35. And in our case, then the bit interval will be 1 over 5 kilohertz, and that leads us to 1 over 5,000 gives us 200 microseconds.